In today's video, we're going to be going over position, velocity, and acceleration. These three functions are going to describe an object's state of motion with respect to time, and this can be seen here on the left-hand side. We have our position, velocity, and acceleration, and on the right-hand side, we can see how they relate to each other. The first derivatives of velocity and acceleration being position and velocity, while acceleration also being the second derivative of position. This can also be determined graphically. Let's say if you were asked to find out information on an object's velocity and acceleration based on its position graph, you know that velocity, we know that velocity is going to be the derivative of position and acceleration is the derivative of velocity. So what we know then is that from point 0 to 8, we have an increasing slope. This can tell us that on the velocity graph, we're gonna be staying above the x-axis from point 0 to 8 and go below the x-axis from 8 to 10. Now from point 0 to 8, we notice a slight change in the curvature on the graph. That's going to tell us the acceleration, or more comparably, it's going to tell us the slope of the velocity. And since the slope of the velocity is the acceleration, that's how we can determine the acceleration also from the position graph. So from point 0 to 3, we see a sharp rise in the graph. This tells us that the acceleration is positive from point 0 to 3, which also tells us that in the velocity graph, you're going to do a positive slope from 0 to 3. Now from 3 to 8, the slope sort of tapers off into the maximum point and then goes negative. This tells us that on the velocity graph at point 3, which is the velocity's maximum, it's going to taper off and go downwards until it reaches 0 or the maximum on the position. And this is also will be reflected in the acceleration graph, where 0 to 3 would be positive, and then you'll see a decrease into the negative region and then negative from 3 to 10. And this is what that would look like in the velocity and acceleration graphs.